Have you ever wondered what actually happens inside a phone charger when you plug it into the wall? How does it take high voltage electricity from an outlet and turn it into power your phone can safely use? Why does the charger not simply send the wall voltage directly to the battery? What happens inside that small adapter before electricity reaches your phone? Let's follow the complete process from the wall outlet to the phone battery. A phone charger is a power conversion device designed to provide electrical power in a form that a phone can safely use. The electricity coming from a household outlet is not normally suitable for directly powering a phone battery. A charger therefore changes the electrical characteristics before delivering power to the phone. Modern chargers can also communicate with compatible devices to determine how much power should be delivered. This allows charging systems to operate efficiently while helping protect the phone and its battery. When the charger is plugged into an electrical outlet, alternating current enters through the input terminals. The input voltage can be much higher than the low voltage power required by the phone. The first stages of the charger are designed to handle this incoming electrical energy safely. Protective components help deal with abnormal conditions such as excessive current or voltage surges. The charger then processes the incoming AC power through its internal electronic circuitry. One important stage is rectification. The rectifier converts the incoming alternating current into a form of direct current. This process is commonly performed using semiconductor diodes arranged to allow current to flow in the required direction. After rectification, the electrical waveform is no longer the same AC waveform that entered the charger. The resulting DC voltage can then be processed by the charger's switching circuitry. The rectified voltage still contains variations that need to be controlled. Capacitors are used to store and release electrical energy rapidly, helping smooth the rectified waveform. This produces a more stable DC supply for the next stage. The capacitor can also temporarily store energy between portions of the input waveform. This is one reason capacitors are important inside many power supplies. Modern phone chargers usually use switching power supply technology. Instead of continuously reducing the voltage in a simple way, electronic switches rapidly turn the electrical energy on and off at high frequency. A control circuit determines how long the switching device remains on during each cycle. This allows the charger to control how much energy is transferred to the output. High-frequency operation also allows the charger to use smaller magnetic components than many older power supply designs. The rapidly switched electrical energy is passed through a high-frequency transformer in many isolated charger designs. The transformer transfers energy from the primary side to the secondary side while providing electrical isolation between them. The transformer also allows the voltage to be changed to a much lower level suitable for the phone. The exact voltage and power range depend on the charger design and charging standard. This stage is a major part of how a charger converts mains electricity into a safer low-voltage output. After the high-frequency transformer, the output is processed again to produce the required DC power. Additional semiconductor components rectify the high-frequency waveform on the secondary side. Filtering components then reduce unwanted electrical variations. The result is a controlled low-voltage DC output that can be delivered through the charging cable. The charger continuously regulates this output so it remains within the required operating range. Modern fast chargers can do more than simply provide a fixed voltage. The phone and charger can communicate using the relevant charging protocol. The phone can indicate what voltage and current levels it is capable of accepting. The charger then adjusts its output according to the agreed charging conditions. This communication allows compatible phones and chargers to support higher charging power when appropriate. Once the output has been regulated, electrical power travels through the charging cable toward the phone. The phone contains additional charging circuitry that manages the incoming power. This circuitry determines how the energy is supplied to the battery. The charger therefore does not simply connect directly to the battery. The phone itself controls the charging process and manages the battery according to its operating conditions. Inside the phone, the charging circuit controls the energy entering the rechargeable battery. The battery stores the electrical energy through electrochemical processes. As the battery approaches its target state of charge, the charging system changes how power is delivered. The charging current may be reduced as the battery becomes increasingly full. Temperature, battery condition, voltage, and other operating parameters can also influence the charging process. Protection is an important part of the entire charging system. The charger contains components designed to protect against electrical faults and abnormal operating conditions. The phone also contains its own protection and battery management circuitry. These systems can monitor electrical and thermal conditions during charging. If unsafe conditions are detected, the charging system can reduce or stop power delivery. The complete process begins when AC electricity enters the charger from the wall outlet. The charger protects the input and processes the incoming electrical energy. A rectifier converts AC into DC. Capacitors help smooth the resulting electrical waveform. Switching circuitry rapidly controls the electrical energy at high frequency. A transformer can transfer the energy while changing the voltage and providing isolation in isolated designs. The secondary side then rectifies and filters the transferred energy. The output is regulated to provide the required charging power. The charger and phone can communicate when a supported fast charging protocol is used. Power travels through the cable into the phone. The phone's charging circuitry controls how that power reaches the battery. The battery stores the energy through electrochemical processes. As charging progresses, the charging system adjusts the current and voltage. Protection circuits continue monitoring the system throughout the process. When the battery reaches its appropriate charging state, power delivery is reduced or stopped according to the charging system's control strategy. So, a phone charger is not simply a device that sends electricity from the wall to your phone. It is a compact electronic power conversion system that processes, controls, and regulates electrical energy. Its internal circuits transform high-voltage AC into controlled low-voltage DC suitable for the phone. The phone then manages how that power is delivered to the battery. That is the basic process behind how a modern phone charger works.